Alright guys, welcome to another tutorial. So today we're gonna make a rigid body FPS character. So with rigid bodies, think about games like Fall Guys or another bunny game, I don't remember the name, where you'd be fighting each other and you can fall over, get hit by objects and stuff like that. So I'm gonna make an FPS version of that. So let's see, here we go. So this is a test scene that I've made. So I have some blocks here. They're all rigid bodies. I have a cannon that shoots a rigid body at you, like a projectile. And then I have this thing here that spins, and you can walk into it and get hit. And then I have some walking platforms and stuff like that. So let's create a character. So let's make that a rigid body. Add a shape, give it a fill, rotate it, make it 90. Then we're gonna add a spatial, call it a head, add a camera to the head. Let's move that up about there. That should be fine. Then we're gonna use a raycast for the feet. So all the feet. Let's call this rigid body player. Now let's add a script. Let's clear up here. Alright, so what do we need? Okay, first we need a jump velocity, acceleration, then acceleration multiplier. For whenever we jump, we could slow this value down and add it to the times it by the acceleration, so it doesn't speed up as quick. Then you need speed, then max speed, and then stopping speed. You don't have to use this, but it's useful. Then we have the velocity that we're gonna use. We need mouse input. Then we'll grab the head, the feet, the camera. Alright, and the body. Let's name that body. Now, so on the rigid body, we need to check continuous collision detection. We need to report one collision, and then we contact monitor, because we're gonna use functions for that. Let's go back in here. In the ready function, we set linear damping to 1, and then we set mouse to be captured. Okay, in the physics process, we set the friction to be 0 if it's not equal to 0. We're gonna use that to avoid being stuck on walls. And then we set is on 4 to be false by default, so every frame it changes it back to false. I'm gonna show why I did that. Then set move input to be 0, then we set direction to be vector 3. So now we get set move input to be equals to get input get vector, then left, right, up, down, and up. Put down first for negative, then up for positive. Then we're gonna increment the move input by the head's z base, x base, basis on x. So that's its x movement. And then on y we use move input with the head that basis z. So you see the reason I have this here. If I rotated the camera directly, the camera, if I rotated it on x, these values would change, and it would make the player move slower or faster depending on how much you turn the camera up or down. So I like to separate them. So add the velocity, lerp it with the acceleration times the acceleration multiplier times delta, and then add central force for velocity with the velocity. Okay, now we check the feet. We see if the feet is colliding. Let's fix that up as a matter of fact. Let's move it down a bit and make it smaller, maybe negative 0.2. That should be good enough. So it's just sticking out the floor a little bit. Enable it as well. Then if it's colliding, we set the friction, we set it back to 1. So we keep setting it to 0 here. Set it back to 1. So the reason I do that is if you jump, sometimes the feet would still be colliding on the following frames, if that makes sense. Let's save it while we're at it. And then we could check in the input action, just press for jumping, and is on floor. Then we could say Acceleration multiplier, set that to 0.1, and then its on floor is now false. Remember that this thing changes it to true, so it's gonna be changed back to false here, and it does it here as well. You don't have to do it, but it's good to do whenever you press jump, you expect it to be false. Then we add the central impulse vector up with the jump velocity. Now we set up rotation. So remember the eyes should be the camera. So we rotate that on X, decrement it by mouse input Y, and view sensitivity times delta. Then we clamp it here to be 80 and 80, negative 80 and 80. You could make your own values here if you want. And then the head now, rotation of Y, left and right rotation by mouse X times view sensitivity. Then we reset it to 0. So now let's get the mouse input. So down here we just check if event equals mouse motion, we get the relative input. Okay, so now in integrated forces, this is a built-in function for rigid bodies. This is where you can safely change values for the rigid body without it affecting the physics process. So we are checking to see if it's at its max speed. Then we change it back to make it stay at max speed. Okay, so with move input, we're gonna check. This is where we stop the player from moving. Like dampening, I tried using dampen, but it doesn't feel right. I feel like I'm still sliding on ice sometimes because the friction keeps resetting here too as well. But I tried removing it, but it doesn't make a difference for some reason. So we're just stopping the X and Z motion because gravity still has to work. So we lerp it from whatever it is to 0 using the stop speed, and our stop speed is at 0.1, sorry. And now we check for if it's on a slope. So we get contact count. If it's at 0, if it's greater than 0, this is what we say here. So we're only reporting one contact. If that one contact is there and move input length is less than or equal to 0.2, then we check if it is on floor, and then we get the normals. If it's like, if the Y normal is less than 9.9, we add a central force of the negative of the normal times 10. So that will push you against whatever slant surface you're at, so gravity doesn't slide you down the ramp. And that should be it. So let's save. Let's go in here. Let's go to our test world here. Let's add him in. Move him over. And good play. Here you go. Alright, so could walk over here. Whoops. Forgot one detail. So, in the RB player, we need to close the rotations. So go to angular axis lock and lock all of these because we're rotating the head instead. So that's where we're getting the velocity from. So you don't have to rotate the player. Then now we can run. So don't lean over or anything. Don't know why I can't jump yet, but okay guys, so the issue is the feet, it was sticking out a bit, so it was going under the collision. That was a weird bug, but push it in a little bit, and it's excluding parent as well, so that's on by default. So now it should work. Walk around. Now we can hit stuff. We can jump. We can climb onto stuff. And you can get hit by stuff. Then now let me give that cannon a player to hit. So hit on the cannon. And then assign target. Set it to be the player. Now I could run it again. Hey. And now I'm getting shot. So you can see that I get hit. So if I was using a kinematic body, this wouldn't affect me at all. So So that's the thing with kinematic bodies, you could push stuff around, but they can't push you around. Okay guys, I'll make this code be available in on GitHub. I'll post a link in the description. So have a good one.